All right, guys. Continuing our chapters on systems, two variable systems. So what we're going to be looking at today is elimination. We've done systems of equations before. We looked at it on Thursday. We're looking at it again with elimination. Now with elimination, we want to get one of the two variables to have the same number in front of it. Then we can add or subtract. Well, here, 3x and 3x are already the same. And since the signs are opposite, we would add. Because 3x plus negative 3x is going to be 0. 5y plus negative 2y, 5y minus 2y gives us 3y. Then we just need to solve for y, giving us 2, and plug it back in to solve for x. So since we got y equals 2, well, we could say 3x plus 5 times 2 equals 7. 5 times 2 is 10. Minus 10 telling us 3x equals negative 3. So x is negative 1. Telling us negative 1, 2 is our solution, the point where they cross. So method of elimination, to use method of elimination, one, we obtain coefficient for x or y. Different sign, same sign. Either one, add or subtract, depending on the signs, and then solve for one variable, then find the other. So if we look at this first example here, we have 2x minus 4y equals negative 7, and 5x plus y equals negative 1. We need to get one of the variables to have the same number in front of it. What do y'all think would be easier to eliminate first, x or y? Why? Because if we look at the x, to get the x's to be the same, I would need to multiply the top equation by 5 and the bottom equation by 2. It's not necessarily bad or wrong to do that, but here we're having to change both equations to get the variables to be the same. Now if we look at the second one, the top one is 4y, the bottom one is 1y. So if I want to get them to be the same, they both have to be 4, yes? Which means I just have to multiply the bottom equation by 4 on both sides. And when we do this here, 4 times our 5x is going to be 20x. 4 times our y is going to be 4y. And 4 times negative 1 is negative 4. Now our y values are the same. Questions on this so far? Since we got the y values the same, we'll put them over the top of each other. If the signs are the same, we subtract. If the signs are opposite, we add. And one way to know if we're getting the correct number is just look at the one we're wanting to eliminate. Negative 4 plus 4. Negative 4 plus 4 is going to give us 0. That's what we want. Negative 4 minus 4 would give us negative 8. That's not what we want. We want that y term to cancel. 2x plus 20x is going to be 22x equals negative 7 plus negative 4 is negative 11. Divide both sides by 22. Telling us x is negative 1/2. Now that we have the x value, we can plug it back in to one of the two equations. So our 2 times negative 1/2 minus 4y is equal to negative 7. Our 2 times negative 1/2 would be negative 1. Add 1 to both sides. Telling us negative 4y is equal to negative 6. Divide both sides by negative 4. Telling us y is 3/2. So our solution is the point -1/2, comma 3/2. I think for the most part we remember doing this in some forms. It's been a while. We didn't do it too much in Algebra 2, did it a good bit in Algebra 1, but that's it. We get one of the variables to be the same and get them to eliminate. Questions on this here? -1/2. Plug it back in, get y equals 3/2, and that's our answer. We feel pretty comfortable with this here. We can plug it back in and check. In example 2, the two systems of linear equations, the original system and the system we obtained by multiplying by a constant, are called equivalent systems because they have precisely the same solution. All we did was scale them up or down to get them to be the same, but they are the same equation. The operations that can be performed on a system of linear equation to produce an equivalent system are interchanging two equations, essentially what we did by adding, subtracting, or substituting, multiplying an equation by a non-zero constant, and adding a multiple of one another to the system. So interchanging, so this is more of our substitution. But we can do any of these three. And that's it. Because I think normally would put more examples, but I feel like we feel pretty comfortable with doing systems. It's nothing new. If we need more practice or if you have questions, ask, we can go over them. Graphical interpretations. So graphical interpretation solutions, we have one of three options. Exactly one solution, infinitely many, or no solution. Now it's infinitely many, not all real solutions. For the longest time I would say all real solutions, but that's not the case. Because it is not all the real numbers. It's not all real solutions. It's an infinite number of solutions. That can be true for this here. Or we can have exactly one where it crosses or intersects at a point. Or we could have the option that there are no solutions. Linearly, it's going to be that the two lines are parallel. Non-linear would be, well, we could have quadratic equations like this here. They don't cross. They're just not going to intersect. So our non-linear equations aren't necessarily, they won't be considered parallel, but they just don't cross. No solution is our no intersections. We didn't get into it too much, but it is possible to have a circle and an ellipse. We do have 4 points of intersection. There are 4 solutions. There's multiple cases that we have. There are more solutions. Number. A system of linear equations is consistent when it has at least one solution. So we call it a consistent, or it is consistent when it has at least one solution. A system is inconsistent when it has none. If it doesn't have any solutions, it is inconsistent. So this here, we have equations and we have graphs. We want to match it and determine the number of solutions that we can have here. So the easiest way is just to solve it, see what we get. So if we look at A, 2x minus 3y equals 3, well, to get or eliminate a variable, either one works. Either one works nicely. And the reason I say that is because if we look at x, we have 2x and negative 4x. What do we need to multiply by 2x to get 4x? 2. So it's a nice number. We're not having to multiply both. So we could do that with x. We can multiply this entire equation by 2. 2x times 2 is 4x. I'm just going to write it underneath. 2x times negative 3y is negative 6y. 3 times 2 is 6. And since the signs are opposite, we would add. Negative 4x plus 4x is 0. 6y plus negative 6y is 0. 6 plus 6 is 12. Well, what happened to all of our variables? They canceled out, yes? Is 0 equal to 12? No. That statement's false, yes? So that means for our number of solutions we have, or our solution is no solution. There is no point of intersection, which means that this is graph II. It's the only one that doesn't have a solution. There is no points of intersection. There's 2 lines there. The other way we could have gotten that is rewritten one of these equations as y equals x 3/2 x minus 1, and that would be still II. And specifically, we would say that this is inconsistent. Nope. Knew it. That should be an E. Inconsistent. Questions on how we solved A and matched it up. B. 2x minus 3y equals 3, x plus 2y equals 5. Y is possible to eliminate first, but I'd stick with x because we have 1x and 2x. It's going to be easier to multiply the bottom equation by 2 to get them to be the same. 2 times x is 2x. 2 times 2y is plus 4y, and 2 times 5 is 10. This time, would we add or subtract? So let's add. 2x plus 2x is, so we're wanting it to what? Eliminate out, yes? Okay, so adding didn't work. Let's try subtracting and see what happens. 2x minus 2x. 0, is that what we wanted? Yeah. So that cancels out, which means we're going to subtract the whole thing. If the signs are the same, we subtract. If the signs are opposite, we add. 4y minus negative 3y. Negative negative makes a plus. 4y plus 3y is 7y. 10 minus 3 is 7, so y is equal to 1. Now we do need to find x, but there's a good chance b is going to be I. Y is 1, x is 3. I'll do the calculations here in a second. The reason I got 3 is just straight from the graph. It kind of told me 2x minus 3y equals 3. Well, we already found out that y is 1. So 2x minus 3 times 1 is equal to 3. Yeah. Negative 3 times 1 is negative 3. Add 3 to both sides, telling us 2x is equal to 6. Divide by 2, telling us x is equal to 3. So if it does give us the graph, it does make this a little bit easier to solve because we can use the graph to find it. Questions on this here? And this here would be consistent because we do have at least one solution. And I'll put the I down here. Oh.
Why does it flip? Like it's like negative and then you're adding and then you're subtracting. Why is it?
Okay, yeah, good question. Why did it flip here in the middle?
Yeah.
So our original equation we brought down was minus, yes?
Yeah.
And so we subtracted, and our negative made a positive. Yeah, and this is one of the nice things, especially with elimination, I will write the minus sign beneath or between each of our terms. One, to remind myself I'm subtracting, because it's very easy to subtract the one we wanted and then just start adding everything. So I put it across all of them. And whenever I get this minus and negative, I'll go on and change it to a plus just so it helps me.
So I was like so confused about how do you get stuff like that if you guys like that?
Yes. 4 minus negative 3. Any other questions? Well, we know that this last one has to be connected to the graph I, because it's the only one left. Now, if we solve this one here, just like with the first one, x and y are both good ones to solve for, or eliminate first. And actually, in either case, we can just take the first one and multiply both sides of the equation by 2. Giving us 4x minus 6y equals 6. Now, if we're eliminating x first, negative 4 plus 4 would be 0. So we can add 6y plus negative 6y would also be 0. Negative 6 plus 6 is 0. So there are infinitely many solutions. Yep. And since we do have infinitely many solutions, it is consistent. And that's why the two lines are parallel. Now, I said earlier that it is infinitely many, not all real, because not every point in the real number system will work for this. Which seems odd because we're used to saying infinitely many, it's everything, yes? How about the point 0, 0? Would this make both statements true? Let's look. So 2x minus 3y equals 3. So 2 times 0 minus 3 times 0. If it's a solution, that should equal 3, yes? Well, 2 times 0 is 0. 3 times 0 is, and 0 minus 0 is. That's why it's not all real. Because there is an infinite number of solutions, because every point on those two lines is a solution, but not every point on the graph makes those two equations true. Because it's every point on this number line here. And the number of points on a line is infinite, so there is an infinite number of solutions. It's just not all real solutions. Because there's just as many points not on the line, if not more. There's an infinitely many more points not on the line than on the line, but it is infinitely many, and it would be consistent. Questions on this here? Let me give explanation. That's it. That is it.